Good morning. Previously, we discussed the electric field between two ideal parallel plates. Today, we are going to look at how it is different if the plates are not ideal.
Flippin' physics.
It starts by discussing this illustration, what it really represents. Each of the plates has an excess of charges, the top plate has an excess of positive charges, and the bottom plate has an excess of negative charges. Realize each of these charges is infinitesimally small. However, I cannot make them infinitesimally small in the illustration or you would not see them. Also, the parallel plates are generally quite thin. They are typically thin sheets of conducting metal. And again, I'm not going to illustrate them that way because then I would not be able to show the charges on the thin metal plates. And the distance between the two thin metal parallel plates is typically very, very small. Usually there is a thin sheet of insulating material, which is basically a sheet of paper between the two thin metal parallel plates. Basically, it's a thin metal and paper sandwich. Hopefully you can see that this illustration, which is closer to what a pair of parallel plates actually looks like, makes it very difficult to visualize the electric field between the two plates. In order to understand the electric field between these two plates, we visualized a test charge between the two plates, electrostatic forces and their components, and that just does not work with the more realistic thin metal and paper sandwich illustration. And remember, even though the parallel plates appear to be one-dimensional in this illustration, like this piece of paper, they are actually two-dimensional planes oriented like this. You can only see one edge of them in the illustration. All right. Previously, we showed that the ideal electric field between two parallel plates can be considered to be uniform and directed from the positively charged plate to the negatively charged plate. And remember, this ideal electric field results from assuming the parallel plates can be considered to be infinitely large. And Billy asked,
but what does a non-ideal electric field look like between two parallel plates?
Yeah. Which is a reasonable question. Sometimes you will see the non-ideal, nearly uniform electric field between two parallel plates illustrated like this. However, it is important you realize the electric field in this illustration contains an error, which is repeated many times. Can you tell me what the error with this electric field illustration is?
Not me. Nope.
The error has to do with the direction of the electric field near a conductor in electrostatic equilibrium, which we learned about last time.
I do not think that helps. Nope.
Last time we learned that the electric field just outside the surface of a conductor in electrostatic equilibrium is perpendicular to the surface of the conductor, and these parallel plates are both conductors in electrostatic equilibrium.
I see it.
What?
At each location where the electric field starts on the parallel plates, the electric field needs to be at a 90-degree angle to the plate. You can see a lot of the electric fields are not drawn normal to the plate.
Oh. Correct, Bobby. This is a better approximation of the non-ideal, nearly uniform electric field that exists between two parallel oppositely charged plates. The electric field right next to the plate is drawn at a 90-degree angle to the plate, and at each of the ends, the electric field bulges out because it is not quite uniform. Another error with this illustration has to do with the charges. Because a non-ideal pair of parallel plates has plates which are not infinitely large, the charges in the non-ideal parallel plates are not quite uniformly distributed. It turns out that the charges will be closer together near the edges of the plates and farther apart near the middle of the plates. However, this illustration is what you usually see when representing a non-ideal electric field between a pair of parallel plates. All right. That non-ideal electric field is good to briefly talk about. However, please realize that typically the electric field will be considered to be ideal unless it is specifically identified as non-ideal. Thank you very much for learning with me today. I enjoy learning with you.